Hope the screen is visible.
It is starting now, sir.
Okay.
It's visible.
Okay. Yeah. Uh, Thank you for inviting me to this guest lecture on emerging trends in the electric vehicle segment. My pleasure being here, part of this webinar, sharing my experience, my learnings, and also, as a part of the seminar, what I'm going to learn out of you. It really gives me an energy to be part of such interactive sessions. So this is the brief of mine. Sir has already given a brief of mine. Yes, 10 years in a corporate life like Bosch Honeywell, and it's been a 10 plus years with slow key and counting. And the later 10 years had really been challenging and learning. It's been a really an exponential curve in the, since the time I started slow key. However, the learnings which I had during my Bosch or Honeywell days really being a foundation to whatever I'm doing today. Uh, so we are a startup kind of an environment. Although it is a 10 plus years, we are again, 20 plus engineers in our office and very agile in nature. This really gives us an edge on, taking up challenging tasks and innovative, coming up with innovative solutions at a much faster pace. Uh, what really challenges, in case of a startup environment in Indian context is basically that we are agile, we are quite fast in coming up with a product or a solution. A bigger organization or enterprises, which generally takes, let's say, around 1 year to come up with a product, we generally take around 2 to 3 months. It's not magic actually, but it's just about the larger organizations are more bureaucratic and also uh, their approach to product development is different than what generally you find it in a startup environment. But what lacks in startup environment or a smaller organizations, basically the procedure oriented approach, methodologies, what is followed to come up with that. So that means to say, the general arguments being done in the industry or a market is the startups, whatever they make, is quite good from the prototype perspective, but not really from the productization. However, what really differentiates Sloki from other startups is the culture that we have it to understand how the product has to be developed. What is that missing gap, which generally we find it in a startup environment, like the process oriented, the approach, and the real culture, what is being adapted in a larger organization. So, what is that culture? Culture is just not just about one person knowing a topic of functional safety or ISO standards or the process for improving the quality and all. The culture, what we generally see in our house, that everybody is aligned. Everybody is following the some set of rules and guidelines. Everybody talks in a similar rhythm of language. So that's what actually we generally find in our office or in our company. Talking more about the maturity, how to mature the product, how should we make it a product which is more reliable. So in a simple terms, what it actually means is there is a huge difference between coming up with a prototype and making it a real product. That means a simple scooter, it could be, let's say, TVS Ntorq or or any motorcycle, motorbike, or cars, whatever we see. All of us will use them as a normal user, and like a layman. But although we really don't appreciate the amount of technology that has gone in, the amount of what do you call, the care which is taken to launch that vehicle, considering all the aspects, not just about the simple design and procurement and assemble it and then sell it in the market. A lot of theoretical knowledge, analysis, research, all those things makes it. That means extreme care is taken so that it looks simple for a normal person like us. But if they don't take the utmost care while designing, a lot of issues will come up, and all of us will actually jump on criticizing it, and putting a lot of feedback in the social media about this and that. That means to say, over a period of time, we have been seeing quality product in the market. The moment if there is a substandard product in the market, we can easily identify that, and then say that this is not really good. I mean, it's not really worth for money what we pay for it. Okay, so uh, feel free to stop me anytime, because I'm not generally a typical trainer or a lecturer. I'm trying to put my experience across here, and then so that it makes more sense. So if you have any questions, feel free to stop me and then ask, so that if you make it more interactive, I'll be happy. Okay. Um, the today's topic, what ma'am said, it's about emerging trends in the software safety for electric vehicle. Okay, let me come to the point actually. Today we are going to talk about the functional safety, that is ISO 26262. I really don't know how many of you have heard of it. Is there a possibility in the Google Meet, uh, which gives a quick survey, that how many of you know have heard of it? The functional safety. Can you type it in the chat box? So any honest answer is welcome here, because the content is prepared basically for giving that awareness. However, the while I am explaining based on the, yeah, the only one responded. I don't know about others, whether they're seeing the screen or having some difficulty on the access. At least if I get some 3 to 5 response, that will be great, so that I can actually. That's a challenge with online training or a seminar. It's also called as functional safety. Another 20 seconds. Yes, no, should be good enough. In the chat box, if you have heard of ISO 26262, you write yes. If you have heard of functional safety, write yes. Otherwise, you can write no. Okay. I don't know. Maybe people are experiencing some. Okay, that's a good point. Autonomous vehicle being hacked. 10 more seconds. Can any of you, is there permission required on the Google Meet to type on the chat box?
No, sir.
Okay, okay. Yeah, fine. Without wasting much of time on this, we'll move ahead. And I would assume, yes, uh, it's not been heard of, and then we can actually deal it from the fundamentalist perspective. Okay. Um, Let me put it this way. There are terms used in the automotive industry called functional safety, or it's also called as, some people call it as FUSA, that's in short functional safety, FUSA. It's also given an ISO standard name called ISO 26262. So they talk about how to make all, basically the system more safe, to reduce the harm or to come up with a strategy to avoid unreasonable risks. So these are the terms, we'll go through it. What is more important is, if you directly jump onto this topic, it sounds really boring and it looks very dry topic. But what is really interesting in this topic is, we all of us know what is safety and what is risk, right? So we ourselves are the best judge on many of the things which we encounter in our day-to-day life. That means we know, we keep talking about something like, the health risk, financial risk, the different risks what we encounter in our life. So the moment when we are talking about, the risk, we immediately also talk about two things. Risk is basically an uh, a state which talks about the failure or the harm, or getting into trouble. So these are the things what generally the risk gives the meaning. And in the parallelly, we also think about what are called, the safety measures. That means when we talk about health risk, immediately, we do take care of, or we give a guidance or support to the others, saying that we really have to be fit, we really have to be physically fit, take a good diet, and so that we really don't get into the health risks. This is the kind of an active safe measures. There's a passive safe measure. That's something like, okay, health is now upset. How do you take care of it? Take the medicine. The medicine is like a passive safety. That means the risk has actually occurred, but you are trying to mitigate it, and that's like a contingency plan. Take the medicine and again be normal. Be like any other normal human being. So these are the different things what we generally take care of. Similarly, the financial risk. In the financial risk, we do, the work, we do earn, we do the savings, we do asset making, we do take insurance. So all of them are actually the active safe measures when it comes to the financial risks. So when the risk means it's like an event, a bad event which actually happens. So you take care of all these measures so that you are controlling, that bad event to occur, or you're trying to avoid it, or if it is inevitable, you are controlling the damage actually. So that's precisely what the fundamental term safety comes up with. So this is the same thing what is used in different domains. It's not new to automotive. This is the functional safety is a word which is used in different domains such as automotive, industrial automation, industrial application, avionics domain, and also medical devices, medical domain. So wherever you go, these are used. but with a different ISO name or a standard or, but the fundamental thing is every domain actually saves the human being or assets or infrastructure. When these items come into the picture, you really have to safeguard these points, and that's where the functional safety slightly differs from domain to domain. Okay, before we get into that topic, let's look at some of the, what is this functional safety and why do we really require it? Because day by day, we are asking for more features. Now I'm referring to the slide actually. More features, that means more components getting into the vehicle, and more of an R&D which is going inside the vehicle, a lot of research activities, and more electronics, more software, pointer option. So more electronics and so more software, more BOM cost, that means bill of material, more of a hardware. And because of the more software, there will be bugs. We also ask for more comforts, so hence it becomes more complex system, and thereby again, there will be a government regulation on many of the aspects. Now these days we are also talking about connectivity, more connected. Someone was typed on a chat box saying that he heard of an attack actually happening on an ADAS system. That's perfectly right, actually. In fact, it has happened. So all this while connectivity was just about, in a true sense, getting connected and you do whatever is intended. But as there are attackers, there are viruses, like how we see it in our desktop or laptop, virus, antivirus, and all these same things are actually coming into this connected world, IoT or connected car domains. Hence, cybersecurity attacks. So with this slide, we'll give you a hint like that there is an increase in the demand, or there is an increase in the wish list of the end user, or the technology is also driving the wish list and creating more demand in the market, and thereby there are side effects, and these side effects you have to overcome, because that is what the innovation is all about, that is what the new R&D is all about. So no company would ever stop innovating, otherwise the company collapses, or it's more of fun for the human being to come up with the new things. He can never stop. That attitude of innovation. Considering these facts, we will look at more on the right top quadrant. That's more electronics, more software, and more bugs. That's what the topic of discussion for the today's thing going to be. When I say, when we know these problems are existing and these problems are going to come, why are we still pursuing these challenges, and why are we still pursuing coming up with a new vehicle when we foresee these challenges? It's something like this. We know a lot of accidents do happen on the roads. Still, we take our vehicle out every day from the home, ride or drive to the office or college or institute, whatever, from point A to point B. This is with an assumption saying that I'm a safe rider or a driver. I really don't get into the situation what I really hear generally in the news or a newspaper. I do take a certain measure, hence I will be safe and I'll reach back safe. So that means to say there are negativity actually happening, across the world, everywhere. There are two ways of looking at it. One, we as a user, we always think positive that this transportation, whether it is a two-wheeler or a four-wheeler, this is meant for certain positive usage. Hence, we bought it and we are using it. And whatever the shortcomings in the vehicle, We do understand that and we use it genuinely and responsibly so that we generally don't encounter any faults or we don't encounter any accidents. At the same time, if you really look at from the OEM perspective, that means two-wheeler manufacturer or four-wheeler manufacturer, they are also constantly thinking of how to make these system more safer in the next release of the vehicle, in the next variant of the vehicle, in the next model of the vehicle, how to make it more comfortable, secure, safe for the rider or the driver. So there is a constant understanding unknowingly happening in the market to make it more secured and safer. So when this is the mindset in the in the whole of the infrastructure, there is absolutely no dearth of coming up with an idea which makes the entire vehicle industry more safer. And for this, we really have to follow certain guidelines, and that's what the functional safety. And there is another term called ASPICE. That's basically the project management, how we handle it to make a safer vehicle for the market. Okay. Before we dwell upon onto the topic, let's understand a couple of the terminologies which are used. As I said, safety. Safety means absence of unreasonable risk. This is a very, very important thing. All of us know, all of us do talk about these words every day. What's really important here is that unreasonable risk is the key word here. That means there is a risk, there is some fault or the situation going wrong likely to happen, but this is acceptable by the society. So that's what unreasonable risk is all about. So either to avoid the problem occurring, or if the problem occurs, how do we control it so that it is still in the acceptable range. So that's what the unreasonable risk. What is a risk? In terms of functional safety, it's basically a product of probability of occurrence and severity of the harm. So that means to say, while I'm driving, if I hit a tree, you know, I fall down while I'm riding the two-wheeler, let's say. What is the harm and what is the probability this happening? Similarly, crashing of a car, how do you actually control certain things? Simple examples would be that how many times can you hit a tree? It's very rare, but this can actually happen. So how do you overcome that? So these are the analysis which are done during the designing of a vehicle. I mean, tree could be a wrong example here, but any failure automatically happening. Hitting a tree is basically an external influence which is not in the hands of the designer of the vehicle. But what if engine getting faulty on its own? So these are the things which generally they think of and then come up with the design criteria. We talked about the probability of occurrence and the severity here. Let's talk about what is the severity. Severity is a quantifiable measure of a harm. So that means when an accident happens, what is the loss we see? So if we quantify it, that's what we call it as a severity. And the probability of occurrence is nothing but exposure. So is it high, low, medium? Does it occur more often or very seldom? So this is the point we talk about. And whenever this occurs, how to control that? Can we control it? Controlling that particular occurrence, is it easy or a medium or a tough? So these are the points that we'll have to understand and proceed, basically for calculation. So this is basically the functional safety part, ISO 26262. This is applicable for any electrical, electronics and programmable electronics equipments. So there is, because functional safety is the word which was coined in 2009 The draft ISO 26262 had come during that time. And any ISO, if you take, although the term is very generic, but they put a boundary. So this is the boundary actually. Initially, in 2009, when they come up, they said it's applicable only for electrical and electronics, and it's only for passenger cars, which are below 3,500 kilo, the 3.5 tons weight. But in 2018, they revised it and then they made it applicable even for trucks and buses, even for motorcycles. And now they are also having a part which talks about how do we take care in designing the microcontroller or a microprocessor, basically the semiconductors. From that perspective, if you really look at it, all these things, what you see, the different functionalities, I just named very few here. Electronic stability or a battery management system or a human machine interface, that's cluster, or active safety system, vehicle control unit, motor controller. Any of them, everywhere you can see the functional safety. So that means any design which is being done in for the automotive segment, the culture of functional safety is really important to talk about so that that inherently be part of the design, and hence the system becomes more safe, and hence at the end a safe vehicle is out in the market and all of us can fearlessly use it. Yeah, we just talked about the definitions actually of these safety, risk, severity, and controllability and all. Based on the same, there is a table which is being given. So don't look at the slide and then get confused. I'll just brief it in a very simple terms. There is something called automotive safety integrity level. That's called ASIL. This is the another term. So let me make the point very, very clear at this point of time. There are certain things which in the industry kept used, something like functional safety or a FUSA or ISO 26262 or then the ASIL, that is ASIL, Automotive Safety Integrity Level. Then there is another something called ASPICE. These are the high level terminologies that we talk about in the coming slides. Automotive, the software process improvement and capability determination. We'll talk about that. What it actually talks about is you cannot take utmost safety measure for all the components that you use in the vehicle, right? So because you cannot be careful all the time, and that's one thing, and you cannot give the same priority for all the components of the vehicle because certain components have got a lower priority, certain components have got a higher priority. Based on that, we really have to prioritize them and then accordingly design the system. So what I mean is basically the the ASIL, the Automotive Safety Integrity Level, has got 4 levels: ASIL A, B, C, and D. So the ASIL D means the highest, most prioritized system, and A means lowest priority system. What it basically talks about is when I say an ASIL is a component or an electronic control unit is an ASIL D, that means if that particular component fails, it can lead to a disastrous situation. That means, a death can happen. So such components are tagged with ASIL D, whereas certain functionalities are more from information perspective or from the luxury perspective, comfort perspective. And if they fail, the person may feel a little bit of discomfort, and hence it can be categorized as ASIL A. And there is another category called QM, what you see, in most of the places in this chart. That's means quality management. That means it's almost equivalent to ASIL A, or you can, just for analysis perspective, you can make it like an ASIL 0 from the easy understanding. ASIL 0 is nothing but QM. But Of course, we really have to follow certain things to make it a QM compliant, but you really don't have to necessarily work on seriously for certain things which are qualified as QM, and so that you don't have to give an importance what is generally given for ASIL D system. Okay, to give a clear perspective of what is generally ASIL A, ASIL D, and how the different components of a vehicle gets tagged differently. We'll just have a look of this. We'll start from here. Let's say engine management system. Generally, it will be ASIL C or a D because the failure of an engine management system can lead to a disastrous situation, catastrophic, even a loss of life. So hence it is ASIL D. Same thing with the airbag system. Here there are two things, both intended functionality. That means why airbag is considered SLD for two reasons. One, this should be designed very, very carefully because when the accident actually happens, it has to get deployed so that you avoid, the death of the passengers or a co-passenger. At the same time, the system has to be designed in such a way that it should not accidentally inflate. That means while you are driving the car in a normal condition, accidentally, airbag should not get inflated and then activated, and so that will again lead to the accident. So that's why both care has to be taken. Instrument cluster, it's ASIL B. In some cases, it could be ASIL A or QM as well. It depends on what is the instrument cluster doing. Uh, you know, rear light, it's ASIL A. That means if the rear light goes bad, goes faulty, and the bulbs are not actually working, nobody will die. So it's ASIL A. But it's more of any comfort for the driver who is driving the backside of your car, coming in the rear side. The rearway camera, again, it's SLB. Getting a false information, that's why they categorize it as SLB. Again, one point I would like to make here that this is just an illustration purpose, like, ASIL C or a D or a B. Of course, they are giving a reasonably right ASIL level here, but in different cars, for the different usage, these ASIL level may vary between, one level here and there because it's little subjective and it basically goes with the final product. What is this vehicle, where is this finally going to be used, what is the target market, and all those things, and hence that will be decided. Brake light, anti-lock braking system is again ASIL D. Active suspension BRC, and vision ADAS is ASIL B. That means camera based, driver assistance or an automated driving. If it is an automated driving, it's going to be ASIL D. Electric power sharing is again ASIL D. This is always ASIL D. And radar based cruise control is ASIL C. Headlight ASIL B, because ASIL, the rear light is ASIL A or a QM, whereas front light is ASIL B, because without which you can't really drive in the night time. So with this background, we can get into the certain topics generally used in the automotive industry. I was telling that there is something called automotive spice. That means automotive software process improvement and capability determination. That means how do you make software less buggy? What are the different methodologies do you use so that you give a very reasonably good software, reasonably good software design or development, how to achieve it? So that's basically the principle that this automotive spice talks about. It is basically a process. It talks about the process, it talks about project management, it talks about the templates to be used, it talks about the philosophy in the organization, how every project, how every engineer, how every the stakeholders who are contributing to the project should be involved, making it more robust. What is important is automotive spice is meant for software only, not for hardware or a system level. Okay, so whereas on the functional safety, they are interrelated, but 26262 or the functional safety talks more about the technology. It is not just about process or a generic templates or something like that. It talks about brainstorming. It talks about a lot of analysis to be done. That means to say, in a very nutshell, if I have to differentiate, automotive spice gives a guidelines whether you are designing battery management system or a motor controller or a hatchback system or a headlamp or an ADAS or whatever. This automotive spice gives the common template process, what is the best practices and lessons learned in the market to be followed for estimation, deliveries, process and all those things. So irrespective of what is the ECU, whereas the functional safety talks about the similar thing but more from the technology perspective. That means it's not so easy that a person who has worked on, let's say, a lighting system can easily design a battery management system. No, because it really requires a thorough knowledge on the technology, the principle of usage, whether, the normal electronics is different from power electronics. The designing of an inverter is different from designing of an HMI. So the functional safety talk more about the technology and how do you come up with a solution, and you should be knowing in and out of that particular topic. So the hence here comes the domain, the technology and the domain knowledge is the very key here in the ASIL part of it. Hope I'm able to make this, a clear distinction between both the topics, because I don't want you guys to get confused, because these are invariably used in the automotive industry quite often. Okay, so of course in the discussion we talk more about the functional safety, and here is one slide which talks about the A-Spice. As I told, A-Spice is mainly from the project management perspective. Project management is the most critical factor in the for the project success. So, what are the best practices that should be followed so that we are on the green side? Whatever you see on the right hand side, green, that's basically a win-win. Both for win-win means both for the suppliers and for the OEMs. That means vehicle manufacturer and also for the ECU manufacturer. The left hand side, what you see on the with the yellow background is a lose-lose situation. That means let's look at the lose, the bad situation for the vendor. Underestimated project. That means sometimes the customer gives under pressure saying that can you deliver this product and we want it urgently by November or something like that. Then the vendor will agree to that, and then they get into an underestimated project. So scope is not really clearly defined and insufficient stuff. Whereas the customer side, it would be a bad situation that they get a very last minute approval from the management and insufficient test environment. Vehicle comes or the electronic comes, but they really don't have a vehicle ready for testing. Everybody is firefighting, and then there is a OEM pressure as well. So that means the management pressure or launch pressure, all those things. So this is like lose-lose situation for buyer and provider, supplier. Whereas a good project management is one where three things are well taken care of. One is the scope definition, the second is the plan and monitor, and then third is the stakeholder management. So these three important points, if they followed, the project getting success is very high. The chances are very high. Scope definition, it's about clearly brainstorming with the customer what are the features they want, and what are the features under what phases they want, and the technology dependencies, and a lot of other factors that can be done. And also the work breakdown structure, that means at a granular level, how different features can be implemented and delivered. Once the planning is done, or the definition is done, you can go for a planning and monitoring, plan the task for the entire team and divide the work, and then continuously monitor whether everybody is as per the plan or not. And then the third is the stakeholder management, which is really important. As you know, to develop one vehicle, there are a lot of people involved, and these people get involved at a different level. So there is a small matrix on the right top corner which talks about this is called power interest grid or a power interest matrix. That means there are people who are really interested in that product project. There are people who are really having a good power in the uh, product. That means in the product development. It could be with any event, for that matter, in your college or institute. There will be some powerful people, or they will. Some people would be having less power. Some people will have a high power. Some people will have a less interest. Along the x-axis, it's interest, and some people will have a more interest. What is important is this right top quadrant. That's important because they have got a high power and a high interest, and you really have to engage them in the project on a day-to-day basis so that they are the key contributors. Whereas the high power and low interest, it's like a highest most authorities in the institute or organization. They have all the power to cancel the program or run the program or make it a success, but they have less interest because they got a lot of other responsibility to take care of it. So they should be basically, you keep them satisfied, keep them informed on whatever is actually happening so that they are happy. There are certain people who have low power and a low interest. So there you really don't have to focus much on them, but keep them informed on what is actually happening so that they come handy when it is really required. So there are other set of people who have got a lot of interest but less power. Basically, they are like an engineers who are interested. They cannot really influence much on the technology part, thereby. But you should also keep them informed and motivated, and because they are the people who are potential to go to this high power and a high interest zone. The A-Spice, again, like how we saw in the ASIL ABCD, A-Spice also has got a 5 levels. Level 0, 6 levels basically, but level 0 is nothing actually. If you don't follow anything, by default you are at level 0. And there are 5 levels, and if we satisfy 3 levels, that itself is great. So I'll go a little faster here. Uh, yeah, sorry,
Slide is not moving.
voice is not audible. Hello,
Slide is not moving, sir.
sorry, madam.
You didn't move the slide, sir.
You're not able to see the slide.
Yes, sir.
One second, I will reshare it again.
We could see the slide, but it is not changing. Now
Okay.
it's not again.
Okay, I will reshare it again.
Okay, sir.
How is it, madam, now?
Yes, sir.
It's good.
Visible.
Okay, okay, yeah. So A-Spice level has got 5 levels, and if we achieve 3 levels, that will be great. And that really is like a very perfect process-oriented organization. And you know, the enterprise thinks that with this level of maturity in the organization, they can really come up with a good product. So this is by and large the comparison between automotive spice and functional safety. Automotive spice, as I told, talks only about software engineering, whereas ISO 26262 talks about a lot of sections. It has got 12 sections basically, and which talks from the concept level, system level, as a vehicle, and from there it goes to the hardware, and it also goes to the software, and it also talks about what are the different processes to be followed, and it also talks about post delivery. That means after the production, how do we do the operation, how is the factories maintained, how to give the services to the end user, so the maintenance, a lot of things it actually talks about. So, as I told, ISO 262, the functional safety has got an improvement in 2018, which now talks about semiconductor and also, the two-wheeler market. So this is the typical V cycle. This is the V is the shape what is generally followed in automotive for their product development life cycle, or this is the development model. The left hand side of the V is talks about the requirement design. When you reach the bottommost tip of V, it's basically the implementation or coding. And the right side of the V, the right wing of the V basically talks about the testing part of it. Different levels of testing, whether it is unit testing, integration testing, and system level qualification testing. So one important aspect that all of us should have and aware of, that ISO 26262 that's meant for automotive is derived out of the mother of all the safety manual, that is IEC 61508. And from there, every other domain started, deriving these functional safety aspects and tailored a lot of guidelines and other things so that it caters to their own sector, such as automotive. There is an IEC 62061 for machineries. For off-road vehicles, there is a different standard. For process industry, it's a different standard. For medical devices, it's a different standard. For railways, it's a different standard. For also for avionics, it's a different one. Nuclear sector and electric devices. So if you really look at, this is the master of all of that from IEC 61508. All the standards have been derived. So this slide just gives you a kind of an FYI, information.
Excuse me, sir.
Yes.
The
Yes, ma'am.
slide is in number 10 only, sir. We could see slide number 10.
Okay, one second. What happened? One second. Oh, so that means you're still here. I don't know what happened. Okay. So is it visible now? 11, 12. Oh, we are in 13 now. Is it visible, ma'am? Hello?
Hello, sir.
Yeah, can you see this?
We could see slide number 13, sir.
13 now. Okay.
13 now.
Yeah. So 13 is what I was discussing about. Yeah, please interrupt me because you let me know if there are any difficulties in viewing or hearing.
Sure, sir.
Yeah. So this is what I was actually mentioning, that IEC 61508 is the mother of all the functional safety guidelines. And from here, a lot of other derivatives have actually come for different sectors, whether it is automotive, for machineries, off-road, process industry, or medical devices, railways, nuclear, and electric device. So 26262 is the number given by ISO for automotive. For a different other sectors, it's a different numbering which is given. You really don't have to remember the number, but what is important, key takeaway out of this slide is basically that there is something once, the main governing manual which is available, and based on that, all other standards have been derived out. Okay. I move on to the next slide. Is it visible? Slide 14.
Yes, sir.
Okay, good. So from 26262 2011 version, although the draft had come in 2009, the first formal version was released in 2011. The next formal release happened in 2018. So 2018, which is released, and they created another standard, but as a new section for motorcycles, functional safety, and also derived 21434, that's a cyber security, because connected cars have come into the picture, hence they created another SAE or ISO standard. And then they created one more standard. It's a derived standard from this 26262, mainly from the ADAS perspective. the autonomous navigation. There they talk more about SOTIF, that is um, safety of the intended functionality. That means in most of the cases we were thinking more of the risks or the problem situation and how to overcome that, so that when the problem occurs, what should be the mitigation plan? When the problem occurs, how do you control it? When the problem occurs, how do you sense it in advance and then take a appropriate measure? That is what the focus had always been since 2011. But when it comes to the functional safety, or when it comes to the autonomous navigation, here, more than the faults, you should also take care of what is normal operation. That means there is no human being to drive the vehicle, and safety is also meant to perform its normal operation also. The positive things, the regular activity also should be thought about how to do the intended functionality. That means when you press the accelerator, its intended functionality is to increase the acceleration of the vehicle. It should not decelerate. When you apply the brake, it should stop the vehicle. It should not increase the unintended acceleration. That means all this while what has been given focus is one thing. Now intended functionality is the other part of it, which should also be considered. So when the SL level is determined, or the process is called HARA, that means HARA, Hazard Analysis and Risk Assessment. Through that process, one generally determines the ASIL level of a system, whether it is ASIL A, B, C, D, or QM. Once that is done, people will also get into what are called qualification of hardware components, qualification of software components, and there is something called proven in use. That means proven in use in the sense, um, let us say, there are certain vehicles in the market which are running on the roads before what was people thought about functional safety. That means there are some vehicles which are in the market which were launched before functional safety came into the picture, and and they are all working fine, and it is already tested in the market. Nobody had ever nobody did not really spend more time on analyzing, doing all the analysis what is required by the functional safety. But they did the design. There are certain things which got failed and now they are absolute. Those vehicles are not there. But there are certain vehicles which got designed very well and they are still running in the market very successfully. So the functional safety will also consider such things. That means proven in use, the time-tested technology, time-tested component, time-tested design. So that is also given priority to consider or reuse it as it is without much of an analysis, because it is also already time-tested. So such an provision is still given in the functional safety. So when it comes to the functional safety, what is important is what I mentioned is this starts from the vehicle level. Then they talk about items and systems and elements and component and parts. That means to say the assay level is determined basically from the vehicle manufacturer, and it boils down to the component manufacturer. The component manufacturers, let's say example, the Mahindra wants to come up with a vehicle, electric vehicle, or the Automotive wants to come up with an electric vehicle. So they make the ASIL determination based on their end usage of the vehicle. And then in that there are motor controllers, there are battery management system, there are HMI, there is a vehicle control unit, and all other airbag, anti-lock braking system, PCM, all of that actually comes as a package. And these ECUs are designed and manufactured by different tier ones such as Bosch, Continental, or the Valeo, Verac, all these players who are basically the pioneers in tier one. They will receive these requirements from the OEMs like Mahindra, or the Tata Motors or Ashok Leyland or whatever, all these OEMs. So that is the first level, the vehicle level definition. Then it will come to the item and the series of requirements. That will boils down to the system level requirements. So that's where they incorporate those functional safety elements into their design and then make it adherence to the customer's requirement. So what it means is, let's say a motor controller designed by Value, it could be SLD for some vehicle and SLC for some other vehicle. But what they generally do is they generally try to attempt to make a motor controller at a standards of SLD and test it and target it for such a vehicle. Then they comfortably claim that it is also SLC because SLD is always SLC compliant and more than that, hence it can easily be delivered. In some cases, you really don't know, the people will start with their system level design. Let's say Bosch may think of coming up with a motor controller or the battery management systems or whatever for a four-wheeler application. Their customer is still not there in their portfolio, and they assume lot of assumptions that the customer may ask these, that, all those things based on their past experience, and they claim saying that this is an SLD with following assumption. And if the customer comes with a requirement which maps with those assumptions, then their motor controller or a battery management system is readily fittable and then deliverable, production ready, something like that. So such components are also called as, when they design it without knowing who is the end customer, they design it with lot of assumptions and categorize it as, from the SL perspective, they call it as SEEOC. That means software element out of context. So these are some of the terminologies used in the automotive functional safety industries. Let's get into a little of a theoretical part of a safety analysis. That means there are different ways of performing the safety analysis. One is an inductive analysis, the other one is a deductive analysis. So inductive analysis is basically a bottom-up approach. That means you go with what is the causes and then finally you identify the effect. That means you know the root causes and then you reach out to the what is the effect. It's basically from the past experience. It's something like this, due to overcharging, we know that it may induce to battery damage. The battery getting overcharged can lead to a battery damage. So so we know that there is a problem doing an overcharging. We also know there is a problem for the battery if we do undercharging or deep discharge or overcurrent, whatever, or over temperature. A lot of these things, we know that. So we know what is the problem and what can it actually lead to a, the vehicle level disastrous situation. So that's basically an inductive method or a FMEA. That's called failure mode effect analysis. We know what the failure and what is its implication or effect. There's another one called deductive analysis. It's a top-down approach where we have seen vehicle getting failed or disastrous situation being seen, and we go in a top-down approach. What is the root cause that actually happened? Something like vehicle crash happened. It may deduce to the steering wheel jam. The steering wheel got jammed and due to the over temperature, the steering wheel actually got jammed because of the over temperature, and due to over current, the temperature was high because over current was there, because there was over torque, or there is a small motor, DC motor inside the steering wheel rod that actually controls this power steering. If there is any fault with that motor, that can lead to the steering wheel jam. So here we saw the final result, and then we drill down to what could have caused because of what, and from there again we go to the this due to is underlined. That means because of that actually, the problem actually happened. And finally you reach to the final level of error, and below that you don't really find the reason, and that's where it actually stops the analysis, and that is the deductive analysis for safety thing. So what this basically means is before you start designing any safety critical system, a lot of brainstorming and analysis is required, and thereby you take the utmost care in designing the system. So this is the continuation of the same thing, and you also get to hear more of this FMEDA. This is for hardware. That means failure mode effect diagnostic analysis. How do you make the design, and how do you diagnose inside the vehicle what can really go wrong? Here it is about the FMECA, that is failure mode effect critical analysis. So what are the critical components that can go wrong? That means to the piece part level. That's what a very important point here. Those of you who come from the electronics background, or the faculties would be much appreciating here that a small component such as an amplifier or a power supply regulator or a small microcontroller or a resistor capacitor, if not considered seriously in the design, that can lead to a disastrous situation. So such critical component, not all components in the PCB are actually the critical component, very few. That should be given the highest most priority, basically from the power stage and the clock. These are the very crucial things for the entire operation that should be given the emphasis. This talks about what is the dependency between all of them. So we talked about FTA here. The deduced deductive analysis is the fault tree analysis. So that's something like this. You can easily analyze. Probably, I'll share these slides across. It's a simple thing like, you have a motor and power source. Two switches are here. When can motor fail? Okay, the motor can fail if there is a cut in the wire, or power source is not working, or one of the switches not, both the switches are not working, and all those things. So this is basically represented in the or AND gate structure, so that it gives you that complete information. This is the template of an FMEA. It's how we actually do the designing of certain things, and how do we come up with the risk priority number, RPN. We can go through one of the case study here quickly. For a digital HMI cluster, how do we manage the temperature? What if an over temperature, what is the functionality? Function being over temperature. The requirement is basically the product shall operate in the range of minus 20 degrees to plus 70 degrees. That is the customer requirement. The potential failure, that could be the temperature within the cluster chamber to go beyond the normal ambient temperature, which is beyond 50 degrees centigrade. What is the potential effect of the failure? HMI does not display anything. The electronic PCB may fail to operate, or the LCD display may fail to operate. What is the severity? Out of the scale of 10, 6. That means if the HMI, the cluster doesn't turn on, the rider or the driver will not die. So we don't give the severity as 10 out of 10. It's just a 6. Of course, it gives a discomfort, or some riders may feel panic suddenly if the cluster turns off. The potential cause, overheating of the components due to non-auto grade component, or ultraviolet. This I am talking about an two-wheeler speedometer. Ultraviolet UV radiation, because the speedometer is open to the sunlight. What is the prevention control mechanism? Selection of the auto grade component. That means whatever the components we use on the electronics, on the PCB, all of them, if it is ensured that auto grade components are used, then we can avoid this problem. Selection of the auto grade component. What is the occurrence? That means what is the probability out of 10 that this can actually happen? Yeah, it's 2 out of 10, or sometimes, ultraviolet radiation 4 out of 10, because uh, the analysis for the ultraviolet is not easy, so it should be done. What is the detection mechanism? So that means when the components are selected by the engineer, some review has to happen whether the component or the part number selected is really adhering to the standard or not. Go open the data sheet, check the temperature range, and check whether it is auto qualified. If so, then we will not get into this problem. So when we are able to detect it so easily with a simple review technique, then that means to say there is a quite a big severity. What are the chances? Yes, it can actually happen because overlooking may happen. That is why we need a reviewer and one approver. Then this can be avoided. And then what is the chances detection? Yes, it is very much detectable, very easily detectable because simple review will help. Thereby the RPN number is 12. So this means it is well within the range because all our components what we choose is between minus 40 degrees to plus 105 degree, and this is well within the range of customers requirement, which is minus 20 to plus 70. Hence we will not encounter this problem, and this RPN number 12 is not really a challenging thing. So what I mean is, this is just I went through this particular thing. I have got one more page of case study, which you can go through it later. And in the interest of time, I'll go a little faster here. So point here is about so much of detailing happens when a particular component is designed and developed, so that there are no surprises in the future, because all these things will definitely be done in the future if not done it in the beginning. It's a very simple thing. Some in the kitchen some accident happens while a woman is working in the kitchen, and after that everybody does the backward analysis, what went wrong, why the your pressure cooker weight actually blew off. A lot of people will talk more of, no, the gasket was not changed since 6 months, there was some issue. So that backward postmortem analysis will actually happen in every house, unknowingly or knowingly. Here in automotive, they try to avoid this post-mortem analysis. Of course, that is always done because unknown faults or unforeseen challenges are always there. But as much as possible, you do that analysis in the beginning itself so that you avoid those issues. So the point here is, if you do the brainstorming on any of the analysis, you always get a good results. This analysis is what is very difficult, and that is why what is being made is they made it as a mandatory so that people are bound to do this analysis so that there are no problem in the system. So I told you in the previous slide, the RPN, the risk priority number was 12, and in some cases it can be 192 based on what is the severity, what is the occurrence, and what is the detection. If you multiply all of them, it will come this. And such a big number topic should be given priority in the design to overcome that. I'll just take a case study of a BMS for an electric vehicle, how the functional safety can be adapted here. There are two ways of looking at it. One is from the software safety requirements and the hardware and the software safety requirement from the quality management. So the problem can happen in the BMS because of the electric shock or energy related hazard or a fire or a heat related hazards, mechanical hazards or a radiation or chemical hazard. So all of them related to hardware and the software. The quality management could be the project organization, responsibility sharing and communication and planning, documentation management, configuration procedures, modification process, requirement management and functional safety assessment, periodic audits. So these, when these are the, with the past experience, these are the possible things which, if it is taken care, then we can easily design a good battery management system. The same thing what we talked about, the safety requirements are considered here, environmental and hazardous situation. So we'll not get into this chemical part of it, like emission of a combustible, toxic, explosive gases and liquids and all those things. We'll straight away jump into the electrical part of it. So it could be an internal short circuit or internal continuity problem, excess internal impedance, and massive shorts in the power output cabling. And there is another environmental conditions like earthquake, vicinity, water, and all those things. We'll not actually consider all of that. Hazardous coming within the battery systems, loss of air conditioning or cooling effect, and what are the possible ways, the hazards that can lead to a BMS failure, loss of battery heating controls, loss of battery voltage control functions, over discharge, over charging, over current, short circuit in the diagnostic cabling, loss of communication with the vehicle control unit. and there is a problem with the microcontroller or a analog front end chips. So what this is talking about is HARA is done, hazard analysis and risk assessments. When you think of all possible failures that can actually happen in a BMS, the battery management system, then for every step, care has to be taken, how to overcome and all those things. And we can give a priority. Let's say the lithium ion battery is very, very sensitive. It operates only within 15 degrees to 55 degrees centigrade. It doesn't work in negative temperature. It doesn't work well beyond 55, 60 degrees. It can even explode also. So the battery cooling is really important. How do you achieve that? If it is an air cooled system, what if fan goes bad and air cooling is not actually happening? What if it is an oil cooled or an water cooled or an active cooling system? And if those pump or whatever the coolant which is getting circulated is actually not really happening, how do you detect that? Do you give highest most priority for this cooling system, rather thermal management? So all of this becomes the crucial part. Based on those analyses, entire BMS will be designed giving highest most priority for the thermal management and whatever priorities to the different sections based on their the CVRT or the RPN number, the risk priority number. As I mentioned in the very beginning, there are 12 different norms basically. They are called 12 parts. Part 1 talks about vocabulary. We talked about vocabulary of some few things such as risk, measure, controllability, exposure, and all those things. How do we do the functional safety management? And then the third is about concept phase. Once the concept is done, in the concept level only we do the HARA, the hazard analysis and the risk analysis. Thereby we will determine the ASIL level of the system. Once the ASIL level is determined, that will give the function safety requirements, safety goals. From the safety goals, we come to the system level, both hardware and software. That's section 4. Section 5 talks about the how do we, product development by hardware, is the product development by software. In the software, how do we ensure the functional safety? Here, how do we ensure the product development considering the hardware design? 7 talks about production, operation, and maintenance, support, services, and all those things. 8 is the supporting processes. 9 is safety analysis, that's a brainstorming. These are the things which are common for all of that, they come in between. How to use the version control, how do you process it, how do you document the customer requirement, and how do you manage all the change requests, everything. 10 talks about guidelines, 11 talks about guidelines, semiconductor. 11 and 12 are the new things. Previously only 10 sections were there, now 11th and 12th section is added. 12th is talks about the motorcycle. Previously motorcycle was outside the functional safety purview. Let's talk about motorcycle safety analysis, the safety integrity level. What has been done here is the motorcycle, in a very simple terms, based on this matrix, the what we saw earlier. Okay, I think we skipped this particular thing. Is the slide number 6 visible now, ma'am?
Yes, sir.
Yeah. So it basically talks about what is the severity, if it is a less severe, medium severe, or a more severe. In every severity, what is the probability of occurrence or exposure, whether it is less likely to occur or more often occurable. So in that case, and what is the controllability? Can you easily control it, or it's very, very difficult to control it? In that case, let's say if you really look at it, it's very easy to control, very less likely to occur, and severity, the damage is also very less. Generally, you see the QM being the tag which is associated with that element, what we design. But if there is a system, the failure of which is basically a highly severe, catastrophic, and occurrence is quite often, and controlling that is also very, very difficult, then it is categorized as ASIL D. So this is the table which talks about based on the severity, probability of occurrence, and what is the controllability. Can you control it or not? Based on that, this chart is prepared. So this particular matrix talks about what type of the particular subsystem of the vehicle should adhere to, whether it should adhere by QM regulations, it should adhere by rules and regulations of the ASIL A guidelines or ASIL B or ASIL C or ASIL D. So same thing is applicable even for two-wheeler. But what is done is for two-wheeler, whatever the four-wheeler, okay, when two-wheeler also the similar analysis is done, but whatever we find in two-wheeler, if it is an ASIL D in two-wheeler, that's called MSIL, motorcycle safety integrity level, it's equivalent to ASIL C of the four-wheelers. So that means if you follow the rules and regulations of ASIL C of the four-wheeler, then it becomes equivalent to ASIL D of the motorcycle. So there is a small relaxation because one important aspect that we should always remember is in case of four-wheeler, there are certain things which are uh, not really the risk, such as balancing the vehicle. In two-wheeler, you have to balance the vehicle. That's a different skill altogether, and this skill is differs from person to person. So what it means is in four-wheeler, when you stop, when the vehicle speed is zero, it really doesn't fall down because there is no balance required. Whereas in case of two-wheeler, this is very much required. And if it falls down, it basically is a harm due to an external condition, not because of electrical or electronics or programmable devices. So certain things which actually is a hazardous situation in two-wheeler, but not in the control of the electronics. Hence, there are a lot of several factors which comes into the picture. That means while you are riding the vehicle, two-wheeler, if it is a skiddy surface, very slippery, and if it is like a sand on the road or a oily or a greasy, then you have more chances of falling down than for a four-wheeler case. So how do you how do you factor in all these conditions for a functional safety is really, really challenging for the things. Because in case of four-wheeler, of course, a slippery surface or a oily surface do matter even for four-wheeler, but you have a electronic stability program which actually makes a vehicle to come to a stable state. But of course, the MSIL, the muscle has brought into the system because you see a lot of the four-wheeler features are also coming into the two-wheeler, such as a drum brake or a disc brake into the two-wheeler, and electronic injection for the thing, and electric car now, electric two-wheelers, same motor controller, the battery management systems, a lot of things. So when so much of advancements happening in the two-wheeler segment as well, why not functional safety? That was the argument, and that's why it has come into the picture. In summary, your development steps and effort depends on the ASIL, because we cannot simply claim just like that I want an ASIL D, because then the project will also take more time, because a lot of documentation process have to be followed, a lot of justifications to be given why this is ASIL D and all those things. Of course, there is another part to that. When you say there are a lot of ASIL-D into the vehicle, that means the vehicle cost also increases, because it is directly proportional to the additional sensors which are put for the diagnostics, additional actuators, or a lot of R&D which goes into that. The OEM will have to recover all of that, and that is finally becomes cost of the vehicle. And hence, it's always absurd in the market that uh, everybody wants to put the ASIL level as low as possible so that they really don't have to adhere to stringent norms. It's a fact, and also it is what even OEM and a lot of people do. Of course, not just by that, with proper justification and arguments and a lot of evidences, that can be proved. Similarly, develop a safety concept with safety requirements and implement a test these requirements on all levels. You have to come up with a detailed use cases, case studies, and then come up with different levels of test cases to test all of these requirements, perform different levels of safety analysis such as FMEA, FMEDA, FMECA, FTA, and so on and so forth. Have an independent person to confirm results of the important development activities, because for any given project there has to be two managers. One is a project manager who takes care of the normal execution of the project. There has to be another safety manager who takes care of all the safety requirements. The one is the functional requirements, the other one is functional safety requirements. So safety is a separate, should be treated as a separate wing to take care of its own needs. Provide an argumentation for the safety in the safety cases. Functional safety requires appropriate measures to assure functional safety throughout the whole life cycle of the vehicle. There is no functional safety without a safety manager. The last one talks about how all of them are interconnected. With this background of what we discussed for last 1.5 hour, ISO 26262 is linked to ASPICE, it's linked to the time to market, it also linked to the brand name because of the most safest car means, the brand name will obviously go high, most reliable. It also adheres to the government regulations. It also leads to usage of the new technology, new trends, and it gives up, it actually leads to a lot of opportunities and a lot of analysis, brainstorming, and R&D activities. This again linked to the future scopes and trends and new initiatives in the mechanical hardware software, such as model-based design and different ways of development. So thank you very much for your patient listening to this webinar, and I'm open for question and answers now.
Yeah, thank you, sir. And the participants, if you have any queries, you can just unmute yourself and ask the questions, or alternatively, you can also post in the chat box.
Yes. If you want me to refer to a particular slide, let me know. I'll go there. Any questions? Good question. The question is basically, what are the functional safety measures taken for autonomous navigation and for the luxury cars? So, luxury is more from the end customer perspective. Uh, there is absolutely not much of a difference between a luxury car or a normal car. Based on the speed or the maximum speed and all those things, higher measures have to be taken care. To answer to your question, one is about uh, you know for the autonomous navigation. Yes, there are different standards which is derived out of the functional safety. So which I talked about, let's say. So I showed this thing that is in the draft. That means what you see in the bottom, the ISO uh, like 21448 on the SOTIF. This is generally used for autonomous navigation. Of course, again for autonomous navigation, you have to do the brainstorm of the entire system, and then the TAM 26262 and the derived safety requirements will actually help, guidelines will help in designing the ADAS system. Same thing for the luxury car, it's the same analysis which will hold good for designing different components of the vehicle. Any other questions?
Shall I read it for you?
And I'll read what is opportunities for automobile engineers from functional safety perspective, any certification required from learning perspective. A good question, in fact. Yes, the certification is required. It's more of a culture now. there are a lot of products being developed because of the demand from the OEM. As you know, automotive market is a very, very cost sensitive market. So people generally don't pitch in and start practicing functional safety unless big gains like Bosch or Conti or some big players. But otherwise, many of the tier ones generally don't get into this functional safety so easily because it really adds cost to their product development, entire R&D and other things. But everybody follows when OEM makes it a mandatory stuff, and hence it's more of a culture which is coming up. This is, I would say, a very emerging part of it. People getting into ASPICE or automotive functional safety is really a very niche area and highly sought after, highly demanding one. They can actually take this certification from, there are a lot of reputed institutes like TUV Sur or TUV Rhineland or Exida. A lot of these reputed institutes who give online offline trainings, and also you can get certified. And there are different levels of certification as well, level 1, 2, 3. And it based when you complete a level 1, and based on that, if you take up some projects and then complete it and follow all the safety, the recommendations as suggested by the norms, then you can take up the level 2 and then qualify. Thereby you can actually get certified. But this is a very good area to venture into. Okay. Any other questions?
Any other questions? Hope there are no more questions, sir.
Okay.
Thank you, sir. Thank you for accepting our invitation and gave a wonderful session on safety standards for EV, sir.
My pleasure,
Thank you
madam.
so much.
My pleasure here.
Thank
Yeah.
you so much.
Thank you.